Okay, Assalamualaikum and good evening, everyone. Today we continue to discuss topic number 12. Topic 12, kinetic theory of gases. So we look for question number 1. Okay, 1 mole of oxygen gas is at pressure, at the pressure P1 equal to 6 atm and temperature equal to 27 degree Celsius. So the temperature, make sure you convert the unit degree Celsius to Kelvin unit. So how to convert? You just plus 173. So you will get 300 Kelvin. Okay. The question is, if the gas is heated at constant volume, so dia bagi kamu hint constant volume, until the pressure triple, so P2 is triple to the pressure 1. What is the final temperature? Dia minta kamu, the final temperature is T2. Okay, look at the figure here. Okay, the right figure. Okay, figure ini dia given. Okay, how to remember, or how to easy to remember the question, the equation. Okay, sorry, the equation of of the gas law. 3 gas law: Boyle's law, Charles' law, and pressure law, or the other name for pressure law is Gay-Lussac law. Then this is to help you remember what the constant for each gas law. For example, Boyle's law. Okay, we look for the Boyle's law. So for the Boyle's law, the equation for Boyle's law is P times V. P times V equal to constant. Okay, apa yang constant pada Boyle's law ini adalah temperature. Temperature is constant. Okay, alright. For Charles' law, okay, for Charles' law, alright, V over T. Okay, V over T. So V over T, V time over T. So this is constant. What is remain constant for Charles' law is pressure. Pressure is constant. Okay, constant pressure. Ini temperature for Boyle's law, temperature constant. And for Boyle's law, for Charles' law, yang constant adalah pressure. P adalah constant. Alright. Okay, for Gay-Lussac law or for pressure law, okay, the equation we use for Gay-Lussac's law adalah P over T constant. Okay, so what the equation, what the value constant for Gay-Lussac law adalah volume is remain constant. Okay, jadi pada situation A, dia kata heated at constant volume. So kita tengok yang constant volume adalah pada pressure law ataupun Gay-Lussac law. So we use the equation P1 T1 equal to P2 over T2. So dalam soalan dia minta kita cari the T2. So T2 equal to P2 times T1 over P1. Okay, jadi just substitute the value. P2 is 3 P2 is 3 P1 over P1. T1 is 300 Kelvin. Okay, cancel out the P1, so you will get 900 Kelvin. Okay, settle for question number A. We go to question number B. Question number A and question number B. If the gas is heated, so both the pressure and the volume are double. So sekarang ini situation dia pula apabila gas itu dia heated. Okay, so both pressure and volume double. So P2 adalah double daripada P1 and the volume 2 adalah double from volume 1. What is the final temperature? Okay, dalam soalan ini dia tidak cakap constant volume or constant apa-apa. So what the suitable equation we use, okay, apa yang sesuai yang kita akan guna adalah equation for ideal gas PV equal to nRT. Oleh kerana kita kata 1 mole of oxygen, okay, sudah, okay, 1 mole of oxygen. So ini 1 mole oxygen lah R. Okay, R ini dia akan remain constant. So P1 V1 over T1. Okay, P2 V2 over T2. Okay, PV and RT ini, okay, ataupun the ideal gas, the equation of ideal gas ini adalah hasil gabungan daripada three law of gases. Okay, Boyle's, Charles, and Galilei's law. So dalam question ini dia minta kamu what the final temperature, dia minta kita cari T2. So the final temperature T2 equal to, okay, P2 V2 over P1 V1 times T1. Okay, jadi just substitute the value P2 3P1 V2. V2 pula adalah mana V2 tadi? Okay, V2 adalah double ini 2A, double sorry. Double P1, P2 adalah double daripada 2P1 and volume 2 is double from volume number 1. So P1 V1 times T1 is 300 Kelvin. So cancel out the P1 and V1. 2 times 2, 4 kali 3, 1000. You will get the answer is 1200 Kelvin. Okay, settle for question B. We go to the next question. Okay, sorry. Okay, the next question is question number 2. For question number 2, dalam soalan ini, a 20 liter tank of carbon dioxide CO2 is at the pressure ini and temperature ini. Okay, yang pertama dia bagi kamu volume 1 is 20 liter. And the pressure 1 for carbon dioxide is 9.5 exponent 5 Pascal. And the temperature 1 yang given is 90 degrees Celsius. So make sure change to Kelvin unit. Okay, so if you change change kepada Kelvin unit lah. So kita tengok question number A. Question number A, apa yang dia minta? Calculate the temperature of the gas in Kelvin. So easy. The temperature 1 is 19 degrees Celsius, just plus with 273. So you will get the answer is 292 Kelvin. Okay, for question number B. Okay, is the ideal gas law to calculate the number moles of the tank. Okay, dia sudah bagi kamu hint, use the ideal gas law. And for sure, for kinetic theory of gas, we talk about the ideal gas law. Okay, ideal gas law from the combination of three gas laws, Charles, Boyle's, and Galilei's law. So use to find the number of mole of gas. So number of mole of gas. We know the equation for ideal gas PV equal to nRT. So you rearrange the equation. N equal to PV over RT. Just substitute the value. P is 9.5 exponent 5 Pascal. V is 20 liters. So 20 liters you change to meter cube. Alright, 20 liters you change to meter cube. So you will get 20 exponent negative 3 meter cube over R 8.31, okay, joule mole per Kelvin, and times the temperature is 292 Kelvin. Okay, 92 Kelvin. So you get the answer is 7.83 mole. Okay. All right. Okay. Question number C. Let's finish question number B, and we go to the question number C. Okay. Use the periodic table to compute the molecular weight of carbon dioxide expressing in the gram per mole. Okay, gram per mole. So gram per mole is unit for molecular weight. Or wait. Alright, okay, sorry, we continue. So dia kata dia minta kamu cari molecular weight, or the other name for molecular weight. Molecular weight ini adalah sebenarnya dia adalah molecular mass. Alright, molecular mass. So the symbol for molecular mass or molar mass is M. Dia M besar. Alright, capital M. Okay, expressed in gram per mole. Okay, biasanya kita tidak akan guna weight lah, sebab kamu pun biasakan weight ini. Or kalau saya cakap, kalau kita talk about weight, or we know how to get weight, the value of weight, we must times it with 9.81 kan, the acceleration, the gravitational acceleration. So usually we change the weight to mass bunny. Okay, alright. So use the periodic table to compute the molecular mass for carbon dioxide expressing in the gram per molecule. Jadi, so how to get the M? Okay, M mana satu? MCO2. Okay, adalah M. Okay, number of molecule for carbon. Kita tahu carbon adalah 12. Okay, 12 just 12 lah dia punya jisim per mol dia, gram per mol dia. Nanti kamu refer to periodic table if you not remember. Okay, plus oxygen. So oxygen we times with 2. Okay, 16 times 2. Okay, why 16? Because dia punya number, inilah number molecule for oxygen. 16 times 2. Molecule dia ada 2. Molecule for oxygen ada 2. So we times to 2. And dia punya jisim, dia punya mass. Okay, mass dia adalah 16. So we will get 44 gram per mole. Alright. So this is answer for question number C. Okay. We go to the question number D. Right. Obtain the number of gram, okay, of carbon dioxide in the tank. Sekarang dia minta, tadi ini tidak punya molecular mass. Sekarang dia minta mass pula. Mass, apakah mass the number of gram? Okay, the number of gram, maksudnya the number of mass lah. Gram, we know the gram is the unit for mass. So mass, dia minta mass pula. Mass pula yang mass M, simbol dia M kecil lah. Okay, you can refer to the figure here. Okay, figure here. What the equation we use to find the value for N, number of atom, number mass, okay, number of mole. Alright. Okay, ini adalah equation yang kita guna. So question number D. So we know to get the mass equal to N times M. Okay, molecular M kecil. Okay, number of mass equal to number of mole times molecular mass. Alright, just substitute. Okay, M. So we will get M. Number of mole. Okay, number of mole untuk the tank of carbon dioxide adalah 7.83 mol times dengan molecular 44 gram per mol. So you will get the answer is 345 gram. Okay. Settle question number D. We go to the question number E. Okay. Question number E. Okay. A fire break out raising the ambient temperature. Okay. Break out. Okay. Bila fire break out, kita raising the ambient temperature. Okay. Jadi T2 ataupun not T2. Dia kata dia akan meningkatkan temperature until mana sudah 204 Kelvin, while at T2 gas of gas leak out of the tank, dan 82 ni pula dia terkeluar, dia leak. Dia apa leak ni? Bocor gas leak sebanyak 82 mass dia 82 gram. So dalam soalan diminta apa ni? Calculate the new temperature of the number of mole gas remaining the tank. Dia minta kamu T2 ini apa, dan juga the mass 2 pula apa. Alright. So how we find the answer is, alright, kita tahu bahawa okay, tadi kita punya suhu awal kita adalah sebanyak 19 degrees Celsius. So just T2 kita hanya tambah change of T plus dengan berapa tadi yang 19 tu. 292 Kelvin. So you will get the answer is 506 Kelvin. Alright. Okay, the new temperature and the number of mole of gas remaining N bah, dia bukan cari M bah ni. Sorry dia bukan cari M2, dia mau cari N, the new N2. Alright, the new N2. So we know the equation is, okay, with N2 equal to M2. Okay, M2 over M besar. Okay, the equation for get the number of mole. Alright, dari mana equation tu dapat? Kita tengok je lah equation di sini. Yang ini. So, what is M2? Okay, M2 pula adalah, M2 ini adalah hasil daripada, dia kata, daripada mass yang pertama 345. Kan, 345 dia kata leak, bocor kepada 82. So, we get the M2, 345 gram. Okay, dia leak lah, dia minus 82. So, apa yang tinggal lagi? Okay. Apakah yang tinggal, berapakah gram yang tinggal, and times over with the molecular mass for carbon dioxide is 44 gram per mole. So you will get the answer is 5.98 mole. Okay, settle for question number E. Question number F. Okay. For question number F, using a technique analog to the example 10.6b, find the symbolic equation for the final pressure negating the change in volume of the tank. Okay, boleh tengok the example dalam software is 10.6b. Okay. The question given adalah, okay, P2 V2 over P1 V1 equal to NR N2R T2, okay, N1 R T1. This equation dari mana kamu dapat? Sebenarnya ini adalah the ratio of ideal gas P1 PV equal to NRT. Ini adalah ratio for for the case number 1 and number 2. Okay, tengoklah. Okay, so dia kata find expression for final pressure adalah P2. So P2, okay, just rearrange this equation. Kamu akan dapat, okay, kita akan dapat P N2 R2, okay, over N1 RT1, okay, P1 V1 over V2. Alright. Okay. Dalam question ini kita boleh anggap bahawa the volume, okay, the carbon dioxide dia adalah remain constant, so V1 adalah bersama dengan V2, so we can cancel out the volume 1 and the volume 2. Ini pun R, the volume of R adalah constant, kita boleh cancel, so we will get the P2 N2 over N1 T1 over T2 times dengan P1. Okay, answer for question number F. Okay, we go to the question number G. Ini kita sudah settle tadi. Okay, question number G. For question number G, calculate the final pressure in the tank as a result of the fire and leakage. Jadi dia minta kamu cari the final pressure. So the final pressure, we just use this equation, okay, P2, okay, N2 N1 T2 over T1 times dengan P1. So N2, okay, N2 tadi adalah 5.98, so N1 adalah 7.83. Kita yang permulaan tadi kan, okay, from mana this value, daripada N is from the value D, okay, and the 7.83 adalah value from the C, okay. So T2, the value of T2 is 516 Kelvin over 292 Kelvin. So we will get times dengan P1. Sorry, P1 kita adalah 9.5 exponent kuasa 5. So tekan calculator. Okay, you will get the answer. Okay, 1.28 exponent 6 Pascal. Okay, settle question number 2. So we go to question number 4. Saya akan bincang question number 3. We go to question number 4. Gas is confined in a tank at a pressure 11 atm and temperature. Okay, dia given kita pressure. Pressure 1 is 11 atm and the temperature 1 is 25 degrees Celsius. Make sure change the units into Kelvin. Just plus 273. So you will get the answer is 298 Kelvin. If 2/3, okay, if 2/3 of the gas, okay, is withdrawn and the temperature is rise, okay, temperature is rise into 75 degrees Celsius, 273, so you will get the answer is 348 Kelvin. Okay, what is the new pressure at the gas? The new pressure of the gas remaining in the tank. So assume the volume tank are not unchanged lah. Okay, kita assume the volume of tank ini dia tidak change. So volume final, okay, akan sama dengan volume initial of volume 2 is same with the volume 1. Okay, jadi dia kata di sini, if 2/3, maksudnya 2/3 of the gas is withdrawn, maksudnya N, okay, N2 kita adalah, N2 adalah 2/3 daripada N1. Okay, number of mole. Alright, jadi equation yang kita akan guna adalah equation sama seperti equation number 3. Number 3 di soalan number F. Okay, soalan number F. So, P2 V2 over P1 V1 nRT2 over nRT1. Okay, so volume there remaining constant, so we can cancel R2, R juga, so kita akan dapat the equation P2 over P1 N2 T2 over N1 T1. Okay, so P2, so we'll get P2 equal to N2 T2 over N1 T1 P1. Alright, N2, just substitute the value of N2. Okay, value of N2 adalah 2 over 3 N1, so cancel out the N1. P2, okay, P2 over 2 over 3. Okay, T1 over T2 over T1 times P1. Okay, just substitute the value of T2 is 348 Kelvin. This one is 298 Kelvin. So we will get NP, okay, 11 ATM. Okay, 11 ATM, dan kita akan dapat the answer is 856 ATM, 856 ATM. So this is the answer for question number 4. Okay, the new pressure. Okay, we go to question number 6. Okay, an air bubble has a volume. Okay, volume air bubble ini yang pertama V1 equal to 1.5 centimeter cube. When it's released by a submarine, okay, by a submarine, dia punya H 100 meter below the surface of the lake. What is the volume of the bubble when it reach the surface? Okay, ini adalah lake. Okay, ini permukaan lake. So, submarine itu below the lake, pada jarak dia adalah 100 meter. Okay, submarine itu dia membebaskan bubble. Okay, dia membebaskan bubble sampai ke permukaan. Okay, permukaan iaitu 100 meter. Okay, so dia mencari what the volume. Okay, the volume, assume the temperature and the number of molecules. Okay, temperature and the number of air molecules and in the bubble remain constant during the ascent, during dia pergi naik pergi atas lah permukaan. Okay, jadi kita tidak tahu kita punya nilai P1. Okay, nilai P1 kita, maksudnya nilai P1 itu pressure pressure pertama itu adalah pada waktu submarine bubble itu di bawah lah, submarine itu di below. So P1 bagaimana, how to find the value of P1? Okay, P1 is P ATM plus dengan rho GH. Okay, rho GH adalah pressure under the lake. Okay, we plus with 1 ATM because ada satu lagi pressure. Okay, pressure yang kita kena tambah dengan ATM di atmosfera di atas the lake. Okay, yang menekan yang di atas adalah atmospheric pressure. PATM, that's why we plus with PATM. Okay, PATM plus pressure under the lake. So P1, okay, PATM adalah 1.13 exponent 5 Pascal plus Rho ini value of rho adalah 100 for water lah, 100,000 kilogram per meter cube. Okay, times dengan 1.8 gravitational, and the height is 100 meter. Okay, 100 meters. So we will get for pressure 1 is 1.08 exponent 6 Pascal. Okay, for P2, okay, apa pula value for P2? The value P2, dia kata what is the volume, dia minta volume kan. Okay, P2 apabila pressure bubble itu sudah naik pergi ke permukaan. So P2 adalah, nilai P2 adalah pressure sama dengan P atm ataupun 1.013 exponent 5 Pascal. So we use the equation of P1 V1 equal to P2 V2. Why? Because we assume the temperature and number of mole is constant. Okay, according to P, V equal to N, R, and RT, this is constant, and constant, this is constant of P1 V1. P1 V1 equal to P2 V2. Just substitute the value, we find the V2. Okay, find the V2, P1 V1 over P2. P1, what is P1? P1 is 1.08 exponent 6 Pascal, and volume 2 is 1.5 centimeter cube. If you want to change the unit centimeter cube to meter cube, okay, boleh juga, no problem. So P2 adalah 1.013 exponent 5 Pascal. Okay, the pressure of ATM, so you will get the answer is 60 centimeter cube for the volume. Volume 2, the volume of bubble when it reach at the surface. Okay, settle question number 6. We go to question number 8. Okay, question number 8. A sealed cubicle container 20 cm on a side contains 3 times number Avogadro, like Avogadro number of molecules at temperature 20 degrees Celsius. Find the forces exerted by the gas on the wall, on one of the wall of the container. So F kita tahu the kaitan of force, dia minta force, kita tahu kaitan force dia dengan pressure. P is equal to force over area. So force is equal to, okay, P times A. Okay, area kita tahu, so the container, cubicle container A area adalah 0.2 meter darab dengan 0.2 meter. Kita akan dapat area for volume 0.2 times 0.2 times 0.2 meter. Okay, alright. Okay, dia kata di sini a site contains 3 times Avogadro number. We know 1 mole sama dengan number of Avogadro, 3 times number of Avogadro. So means for N adalah 3 mole. Okay, sebab dia kata contains 3 times Avogadro number, 1 mole bersamaan dengan 3 number Avogadro, ataupun 1 mole sama dengan 1 sama dengan number of Avogadro. Sorry ya. Jadi dia kata 3 times, so N kita dah akan dapat 3 moles daripada number of Avogadro. Dalam question dia bagi kita apa lagi? Dia bagi kita the temperature is 20 degrees Celsius. So just change the unit into Kelvin, plus with 273. So PV is equal to nRT. Okay, the ideal gas PV is equal to nRT. So P is equal to, because we want to find the pressure. Okay, untuk kita masukkan dia inside the value into the this equation to find the force. So P equal to nRT over V. So N is 3 mole. R adalah 8.31. Temperature kita tadi. Okay, temperature 293. Okay, over the volume. What is the volume? Inilah 0.2 kuasa 3. Okay, you will get 0.008. Okay, so you will get the pressure is 9.13 exponent 5 Pascal. Okay, so jadi kita boleh find the force exerted by the gas. Okay, 9.13 exponent 5 Pascal, area 0.2 dia darablah kan. 0.2 kuasa 2. So we will get the answer is 3.65 exponent kuasa 4 Newton. Exponent 4 Newton. So the answer is this one lah. Okay. Okay, we go to the second last question. Okay, second last question. Dia kata, use the Avogadro number to find the mass of helium atom. Just refer this ni semula lah yang ini kan. Okay. So dia minta cari number mass of helium. Mass of helium. Berapakah mass of helium atom? Kita tahu helium ini adalah dia mempunyai one atom sahaja. Okay, dia one atom. So we know, alright, N is equal to M over M. Okay. N equal to N over NA. Daripada mana? Daripada inilah, this equation lah. Kita tengok. Ini kan N equal to MA. M over M. Tapi dia minta kita cari M. Okay. M. So, N, what is N? Just substitute value N over NA. Sorry, A besar. M over M. Okay, mass inilah yang kita akan kita cari. So, M equal to N over NA M. Okay, molar of M adalah molar of mass bagi helium. Okay, so M kita akan dapat M. N itu apa? Number of atom of helium. Kita tahu helium ini dia hanyalah satu number atom sahaja. Maksudnya kalau O2 oxygen, so dia ada dua number atom. Okay, dua number atom. So kita inside for N is 2 lah di sini. Tapi oleh kerana helium adalah satu sahaja number atom, so we insert for N, value for N adalah 1. Okay, N over number Avogadro 6.22 exponent 23. Okay, darab dengan M lah, number molar of molar mass of helium di dalam kamu punya apa tu? Di dalam periodic table. Okay, adalah 4 exponent negative 3 kg per mole. Okay, so we will get the answer is okay, kamu tekanlah kalkulator berapa di sini. 6.64 exponent negative 27 kilogram. Betul kan ni? Cek balik kah? Ini coba kamu tekan kalkulator for exponent negative 3 over 6.022. Okay. Okay. Settle for question number 9. We go to last question. A 7-liter vessel containing 3.5 moles. Okay, volume dia beri kita 7 liter. contains N3.5 mol of ideal gas at pressure 1.6 exponent kuasa 6 Pascal. The temperature of the gas, okay, find the temperature of gas. Okay, oleh kerana dia kata an ideal gas. So ideal gas is the equation for ideal gas. Okay, PV equal to N RT. Okay, the temperature P 1.6 exponent 6 Pascal, volume 7 liter, change units liter to meter cube. So you will get 7 exponent negative 3 meter cube. Okay, the value of N 3.5 and the R is 8.31 temperature. So the temperature is 385 Kelvin. Okay, for question A. For question B, the average kinetic energy, KEAVG is 3/2 KBT. Okay, 3/2. The value of K is constant. That can given 1.3 at exponent negative 23. Temperature is 385, so you will get 7.797 exponent negative 21 joule. Question B, and the last question. What the additional information would you need if you were asked to find the average speed? Okay, the additional untuk cari kita find average speed V, apa yang kita perlu tahu adalah the molar mass of the gas. What is molar mass? Okay, what is molar mass? The molar mass is M, capital M. Alright, okay. Okay, that's all for question for discussion. Question number F.